Good afternoon. Am I audible? Okay, then we move on to our next numerical. Okay, you kindly write down the equation of the next numerical. So the next question is if Fn is the Froude number at the normal depth Yn, the Froude number for the normal depth is denoted by Fn. Okay, for a rectangular channel, then we have to find out the value of Yc by Yn. Okay, have to find the value of Yc by Yn in terms of F. Okay, so definitely first we are going to use that critical depth equation for rectangular channel, that is q square divided by g, okay, to the power 1 by 3. Okay. We are going to use this equation, and small q we all know is searched by width of the channel. Okay. In place of this search we can write area into velocity divided by v. Okay, then again small q is equal to area is nothing but for a rectangular channel it will be b into yn, as this depth is normal depth, so that is why we have considered yn multiplied by velocity divided by v. Okay. So this b will be cancelled out, so small q is nothing but v multiplied by y. Okay. So that is why in place of small q here it is written vyn, v multiplied by yn, so it is square, so that is why it will be whole square divided by z to the power 1 by 3. Okay. So this will be the next equation. Yc is equal to v to the power 2 by 3, because here is square and then to the power 1 by 3. So it will be 2 by 3. So yn also it will be 2 by 3 and divided by g to the power 1 by 3. Okay. So this is the yc value. But we need to find out the value for yc divided by yn. So that is why we have to divide it both sides by yn, okay, to get this yc by yn. Okay. So we are going to divide the yn both the side. Okay. Here yc divided by yn, and in the right hand side also we have to divide by yn. Okay. And then see if you here we have y to the power 2 by 3 divided by yn. This is nothing but yn to the power 1 by 3 minus 1 by 3. So you can write this thing. Okay. To simplify, you'll get this. So now what we have to do, we have to find this value in terms of Fn. So Fn again, Fn is nothing but your Froude number. This is nothing Vy. root over gyn for a rectangular channel. Okay, so this is the equation. So now we have to find this expression in terms of fn. So we have to substitute that fn. Okay, so we have v and then root over g. So to introduce that fn in that equation, you see we have v, g and yn. So it will be to the power 2 by 3. Here we have taken root over, that is root over is nothing but half. Okay, so ultimately it will be 1 by 3 if you solve again. So in place of this we can write fn, so fn to the power 2 by 3. This is the relationship. So then we move on to the next numerical. It's very simple. Next numerical. What is given? That supercritical flow occurs at Froude number is given, at a depth is also given in meter for a rectangular channel. Find out the critical depth. Okay. So the we all know critical depth for a rectangular channel is nothing but 2 square divided by g to the power 1 by 3. So we need to find out the yc value. To find out yc value, first we need to find out the small q. Okay, the small q is nothing but surge divided by width of the channel. So this surge is given? No. Width of the channel is given? No. So what we are going to do? In place of discharge, we will take area into velocity, okay, divided by b. Okay. Area again b into y. Y value is given. Okay, is given 0.63. Okay. Y value is given 0.63 multiplied by velocity divided by b. Okay. So b will cancel out. It will be small q is equal to velocity multiplied by y. Okay. So in this, to find out the q value, we need depth of flow and velocity. Okay, so velocity is not given in this question. Okay, but this depth of flow is known to us. Okay, so now we need to find out the velocity first, then we can find out the q value, then we substitute this q value in the critical depth equation, and then we can find out the required critical depth. Okay, so now fraud number is given. Okay, so we use the fraud number equation, ey root over gy. Okay, the fraud number is given to velocity is not known to us, root over 9.81 into 0.63. Okay, so from this equation, if you see, the only we have unknown is velocity, so you can directly find out the velocity. Okay, once you find out the velocity, you substitute here in this equation and find out the q value. Once you calculate q value, you substitute here, q value you substitute here, g is, we all know, 9.81. Okay, then you can find out the yc value directly. Try to solve this one and see you are getting the same value or not, that is 1 meter. So we move on to the next numerical. Okay, first write down the question. The discharge of 16 meter cube per second flows in a 8 meter wide rectangular channel. So width of the channel is given 8 meter, discharge is also given, it's 16 meter cube per second, and under critical flow condition. Okay, Find the depth YC. So we need to find out YC, and then for this particular YC, we need to find out specific energy. Okay, this minimum specific energy. We all know at critical depth we have minimum specific energy. Okay, so we need to find out the minimum specific energy. Okay, and also we need to find out critical slope using Manning's equation. You first write down the equation. Okay, why I'm saying using Manning's equation, because the Manning's n is given 0.015. Okay, we have to use Manning's equation to find out the critical slope. But before that, we need to find out the YC value. Then we need to find out the minimum specific energy, or you can say specific energy corresponding to your critical depth. So we all know that for a rectangular channel, that YC equation is Q square divided by Z to the power 1 by 3. Okay. So again, Q is equal to discharge divided by width of the channel. So discharge is also given. So it's not 60, okay, it's 16, 1 6. Some printing mistake is there. It's 16 divided by 8. So it will be 2 meter per second per meter. Okay. So 2 meter cube per second per meter. Okay. That Q value is 2. Okay. Then you substitute here in this equation, Q is equal to 2, and then you find out the YC value. That is 0.741. The first part is over. Then we need to find out the specific energy for that critical depth. Okay. So this expression we have already derived. Specific energy, critical specific energy, or specific energy at critical depth is equal to 3 by 2 YC. Okay. I think we have already derived in the last class. Okay. We are directly using this equation, or if you don't remember this expression, you can use this expression also. EC equal to YC plus BC square divided by twice. Okay. Only that Y value you have to consider that critical depth that you have calculated just now. Okay. Or else, to save your time, you can directly use this expression and you can find out the EC value. Okay. So it is 3 by 2 of the critical depth of flow. Okay. So you will get the specific energy, 1.11 meter of water. Okay. So now the last part is to find out the critical slope. Okay. So we are going to use the Manning's equation. I think Manning's equation is now familiar to you all. It is 1 by n r to the power 2 by 3 sb to the power half. As we are talking about critical flow condition, so this sb is will be sc. Okay. In place of sb, you can write sc. So in this equation, velocity, if you remember, small q is v multiplied by y. Okay, we have already derived this expression. Okay, so for velocity, So velocity, to find out velocity, you can use this equation also. Okay, or Froude number. Okay, for critical depth, Froude number is 1. Froude number equation is nothing but root over gy. So that Froude number is equal to 1 for critical depth or critical flow condition. Okay, so if you see from this equation also, you can find out the velocity, or velocity equal to discharge by area. You can use this equation also, find out the velocity. It's up to you which equation you are going to use. Okay, here they have used this equation, Froude number equation. That Froude number is 1, so it will be cross multiplied and find out the velocity expression. So in place of velocity, they have written gyc. Okay, so 1 by n value is already given in the question. Okay, r is equal to a by b. Okay, for a rectangular channel, I think this thing is very familiar to you all. Okay, and then yc to the power half. So from this equation, all the parameters are known except that yc value. So you can find out the yc value from this equation. So you try to solve and see you are getting the same value or not. Yc here is given 0.003045. So you write down the next numerical. Okay. What is given here? If y1 and y2. Okay. If y and y2 are the alternate depth in a rectangular channel, then we have to prove this. Yc whole cube is equal to twice y1 square y2 square divided by y1 plus y2, and the specific energy is this. Okay? So you write down the question. Okay? Okay. So let's proceed to the solution. So as an equation is given, y1 and y2 are the alternate depth. So we are going to consider E1 is equal to E2. First, we are considering E1 is equal to E2. Then we will write the expression for E1, that is your y1 plus E1 square divided by twice z is equal to y2 plus V2 square divided by twice z. Okay. Then we are replacing that b value by q by a. Okay. And similarly, and here also similarly, okay, that q square divided by a2 square. Okay. Then again, area again we are going to, or say q is equal to, small q is equal to research divided by per unit width. So in place of capital Q, you can write small q multiplied by b. Okay. So we substitute that q or replace that q value by small q multiplied by width of the channel. Okay. So q square v1 square, q square v1 square. Okay. And similarly here also q square v2 square, and other terms will remain same. Okay. We have to first consider E1 is equal to E2. Okay. So after that, so we are replaced here. We have replaced that discharge by small q multiplied by b. Okay. The next line, then we know yc is equal to yc cube is equal to q square divided by g. You have q square divided by g, okay, and other terms will remain same. Okay. So y1 plus b1 square divided by twice a1 square, and that q square divided by g, you can directly write ycq here also. Okay. Other terms will remain same. Okay. Only that q square divided by g, in place of q square divided by g, we are going to write ycq. Okay. Now here in the next, y1 will be same, then we are going to use the area equation. Okay, so here b1 square divided by twice will be there, twice will be there. So in area we can write b1 square y1 square, as it is a rectangular channel. Okay, and ycq will be there. Similarly here also, in place of y a2, we can write b2 square multiplied by y2 square. Okay. So b2 square will be cancelled out. Here also b1 square will be cancelled out. Okay, you can write down the remaining. So you can see that the remaining will be your y1 plus, here you have yc cube divided by twice y1 square. Here also y2 plus yc cube divided by twice y2 square. After that, you take LCM here and you find out this expression. Take this twice y1 square here, so it will be twice y1 cube plus yc cube. Okay? It's a simple mathematics. Okay. Here also similarly, if you consider this twice y2 square, if you multiply with this, it will be twice y cube, y2 cube plus yc cube. Okay. Then you cross multiply. Okay. This two will be cancelled out. This two and this two will be cancelled out. And then you cross multiply. Cross multiply. Okay. It will be, if you cross multiply, it's twice y1 cube y2 square, then plus yc cube y2 square, then plus here again if you cross multiply in this way, twice y2 cube then y1 square plus yc cube is there, then multiplied by y1 square. Okay. So if you, again we are going to find out the expression of yc cube, so we bring that yc in the left hand side. Okay, and you take common. Okay, I think this thing is familiar. Okay, it's similar to the previous problem that we have solved. Okay, first problem or first numerical today we have solved, it's similar to that one. Okay, we take yc cube common, then will be y2 square minus y1 square. So this is again your a square minus b square. So in place of this we can write a plus b minus b. Okay, this two will be cancelled out, and you will get the remaining, or you can say yc cube is equal to twice y1 square y2 square divided by y1 plus y. And in the second part, I think we have two parts in this question. Once you are Till here it's done. The second part, then we have to find an expression for specific energy. So we are going to use the specific energy equation I1 plus V1 square by twice Z. Then that velocity is again replaced by Q by A. Then the discharge is again replaced by small q multiplied by width of the channel. Okay, very much similar that we have applied in the first case. Okay, then again q square by z, in place of q square by z, again we are going to substitute yc cube. Okay, yc cube. Other terms will remain same. Okay, so then again in the next line, we are going to replace that area by b1 square into y1 square. This b1 square will be cancelled out. What will be the left? What will left out is yc cube divided by twice y1 square. Yc cube divided by twice y1 square. Y1 square. Okay. Y1 plus yc cube divided by twice y1 square. Okay. Then we have to replace this yc cube by the expression that you have just now you have derived by this expression. For the first case, you have derived yc cube is equal to this. This you have to substitute here. You have to substitute here. Okay. That means you cannot solve the second section without solving the first one. Okay. First, you have to find out the expression for yc cube that we have just now we have derived, and then that expression you have to substitute here. Okay. This is your twice y1 squared. Okay. So you substitute here and you do simple simplification, you will directly get the required expression. Yc cube is twice y1 square y2 square divided by y1 plus y2. Then again we have here twice y1 square. So this 2 will be cancelled out. This y1 square is also cancelled out. Okay. When you do simple this LCM, you take LCM and do the simple simplification, you can directly get this expression. Okay. So you try to solve this. Okay, it's very simple. If you are not able to solve, then you just let me know. Then we will solve again. Okay. Yes. Because from 1 you have another class from 1 p.m. Okay. So I'm going to end this class here. Okay. So you try to solve at home. Okay. I think that 50% I have already solved. Okay. And that question you have already written. Okay. So you try to solve at home. Okay. If you find difficulties, then just let me know in the next class. We are going to discuss again. Okay. So we are going to end this meeting here because from 1 p.m. you have another class. Okay. So I'm a little bit late today because of this poor network. So thank you, students.